On a typical evening, people across the world were checking their social media feeds when an extraordinary announcement from astrophysicist Neil deGrasse Tyson shook the scientific community and the general public alike. Asterisk, Pluto has just collided with Neptune, and something terrific is happening. Asterisk Tyson, known for his charismatic presentations of cosmic phenomena, had declared an event that, if true, would be nothing short of monumental for astronomy and humanity's understanding of the solar system. But could this be possible? What does it mean? And what exactly is terrific about such a catastrophic event? This fictional scenario paints a picture of a celestial occurrence that many would consider apocalyptic or, at the very least, utterly transformational. Let's explore the implications of such an event, while grounding ourselves in current astronomical knowledge about the two planets, their orbits, and their significance in the grand tapestry of the solar system. ### a scientific absurdity. Could Pluto and Neptune really collide? First, it's essential to clarify the actual mechanics of planetary orbits. In reality, Pluto and Neptune will never collide. Despite the fact that their orbits cross paths, these two celestial bodies are locked in what astronomers call a resonant orbit, specifically a 3:2 resonance. This means that for every 3 orbits Neptune completes around the Sun, Pluto completes 2. Because of this orbital synchronization, Pluto and Neptune always remain far enough apart, and their trajectories never put them on a collision course. However, in this hypothetical scenario where the unimaginable happens, we must wonder, what if something intervened, something so powerful that it disrupted their delicate orbital dance and caused a direct collision? ### the hypothetical impact. What would happen? A collision between Pluto and Neptune would be cataclysmic on a cosmic scale. Despite Pluto's classification as a dwarf planet after its controversial 2006 demotion by the International Astronomical Union, IAU, it still boasts considerable mass. At about 1/3000th the mass of Earth, Pluto is small but dense, composed primarily of ice and rock. Neptune, on the other hand, is the 4th largest planet in our solar system, a massive ice giant nearly 17 times the mass of Earth, composed primarily of hydrogen, helium, and methane. The sheer energy released from the collision would be unimaginable. We are talking about an event so powerful that it would dwarf most astronomical phenomena we've observed in the solar system. Depending on the velocity of the impact, the collision could result in the disintegration of Pluto, with pieces of its icy and rocky body scattering throughout the solar system. Neptune, while far larger, would still suffer significant disruption. The shockwaves from the collision could potentially affect Neptune's core, atmospheric dynamics, and even its orbit. One possibility is that the collision would send large fragments of both Pluto and Neptune hurtling into the outer solar system, creating new asteroids or even dwarf planets. These fragments could be pulled by the Sun's gravity or flung outward toward the distant Kuiper belt or Oort cloud. If some of these fragments were on a trajectory toward the inner solar system, they could even pose a potential threat to Earth or other planets. ### the terrific element. What could Neil deGrasse Tyson be referring to? When Neil deGrasse Tyson says something terrific is happening, he's likely using the word in its classical sense. Something awe-inspiring or profound, not necessarily good. In this case, the terrific outcome may refer to the scientific implications of such a collision. The collision between Pluto and Neptune would offer unprecedented insight into the composition of these distant worlds. For Pluto, scientists would be eager to understand its internal structure, which remains largely a mystery despite the 2015 flyby of the New Horizons mission. The impact could reveal details about the makeup of its icy surface, its subsurface ocean, if it exists, and its geological history. Pieces of Pluto launched into space might provide samples that future missions could study up close, leading to breakthroughs in planetary science. Neptune, too, would reveal secrets that have eluded astronomers for centuries. Its atmosphere is one of the most dynamic and mysterious in the solar system, with supersonic winds and massive storms, including the famous Great Dark Spot, a storm system comparable in size to Earth. The collision could disrupt this atmosphere in ways that provide new clues about its formation, the nature of its internal heat, and how its magnetic field interacts with the solar wind. Moreover, if the collision disturbed Neptune's moons like Triton, a moon believed to be a captured Kuiper belt object, it could trigger a cascade of fascinating celestial events that could be studied for decades to come. ####A collision's impact on the solar system. A Neptune-Pluto collision would also affect the gravitational balance of the solar system, particularly in the outer planets. As massive as Neptune is, any disruption to its orbit could send ripples through the gravitational interactions between planets. Uranus, for example, could be affected, potentially altering its unusual sideways tilt and orbital dynamics. Further out, the Kuiper belt, home to countless icy bodies and dwarf planets like Pluto, might experience a seismic rearrangement, sending objects tumbling into new orbits. This collision could even indirectly impact Earth. If the orbits of distant celestial bodies were perturbed, there's a possibility that large asteroids or comets could be knocked out of the Kuiper belt and sent speeding toward the inner solar system. While the likelihood of one of these objects hitting Earth remains low, the odds would increase in the aftermath of such a cataclysmic event. ####. What if it really happened? The aftermath. In the immediate aftermath of the collision, the solar system would be in a state of flux. Pieces of both planets would likely fill the void of space, forming a debris cloud that could be detected by telescopes from Earth. This new debris field might resemble the asteroid belt, but on a more chaotic and less predictable scale. Over the long term, the collision could have lasting impacts on the solar system's structure. Neptune's new orbit, if altered, might place it on a collision course with other celestial objects, or it might eventually stabilize in a slightly different position. The debris left over from the collision might coalesce into new moons, dwarf planets, or asteroids, reshaping the landscape of the outer solar system. #### Humanity's response. How would we react? The announcement of such a collision would send shockwaves, not just through the scientific community, but across the globe. While professional astronomers would be busy analyzing the data and monitoring the aftermath, the public reaction would be a mixture of awe, fear, and fascination. Media outlets would cover the event nonstop, with headlines speculating on everything from doomsday scenarios to exciting discoveries. Space agencies like NASA, ESA, and others would likely scramble to adjust existing missions and potentially plan new ones to study the collision. Telescopes around the world, including space-based observatories like Hubble and the James Webb Space Telescope, would train their eyes on Neptune and Pluto's remains to capture every detail of the event. Private space companies, such as SpaceX, might even propose ambitious missions to retrieve fragments of Pluto or explore the debris field left by the collision. In the educational sphere, the event would become a centerpiece of science curriculums, with children learning about planetary science in real time as the events unfolded. The collision would likely inspire a new generation of scientists, eager to explore the mysteries of space and understand how such a cataclysmic event could occur. #### Rewriting the books on planetary science. Ultimately, the terrific event of a Pluto-Neptune collision would rewrite what we know about planetary formation, dynamics, and the broader workings of our solar system. It would likely lead to breakthroughs in understanding the history of the outer planets and the Kuiper belt, shedding light on the processes that govern planetary orbits and the gravitational relationships between celestial bodies. This event would also force scientists to reconsider the stability of the solar system. Up until now, the orbits of planets have been considered relatively stable over long timescales. A collision of this magnitude would challenge that assumption, prompting new questions about how often planetary systems experience such dramatic disruptions. #### Conclusion. A cosmic reminder. While the collision between Pluto and Neptune remains a hypothetical thought experiment, one that, thankfully, will never occur, it serves as a reminder of the dynamic and ever-changing nature of the cosmos. The universe is not a static place, and while events like planetary collisions may be rare, they are not impossible. Should such an event ever take place, it would forever change our understanding of the solar system and offer a once-in-a-lifetime opportunity to witness the raw power of cosmic forces at play. Neil deGrasse Tyson's imagined announcement of something terrific happening would likely be an understatement. The scientific discoveries and mysteries unraveled from such a collision would keep humanity's curiosity ignited for generations, reminding us just how small and fragile our place in the universe really is.